Question 1 says, what's the following example of something that's not a square matrix? In this case, we've got an inverse matrix has to be a square matrix. A transition matrix is generally, yes, a square matrix. Permutation matrix would involve some sort of shifting of the numbers, but if you had, for example, a 1, 2, 3, a permutation matrix would need to be a 3 by 3. So yes, that would be a square matrix. And the last one is communication matrix. That would also be a square matrix. So A has to be the answer for that one. Look at question 2. Question 2 says students can select woodwork, fashion, coding. Matrix A shows the number of students who choose each elective. When A is added to matrix B, what does the information show? In this case, we've got D, the total number of students in both classes A and B who choose each elective in this case. Question 3 asks us, which of the following matrix doesn't produce a matrix with 5 rows and 3 columns? In this case, if we look at the rows and columns of this one, this is a 3 by 5 and this is a 5 by 3. You can see we want 5 rows and 3 columns at the end. This one only gives us a 3 by 3. Let's just take another one for example. This is a 5 by 1 and this is a 1 by 3. So yes, it will end up with a 3 and a 5 and 3 in that point. So that means we've got C as the correct answer for this one. Alright, question 4 talks about a particular scalar multiple in this case. So we need to work out what that is. We go 13.8 divided by 11.50 and we get the answer 1.2. So if we go 15 times 1.2, we get an answer of 18, and E is the answer in that case. Alright, question 5 talks about possible flight routes from V, W, X, Y, and Z. It says how many ways can people travel from town Y to town B without using the same route more than once. So we want to get from Y to V. And if we investigate this situation, we've got to go from Y to V. Well, we've got YV as our first route, so we've got at least one. But we can also travel from Y to Z. So we'll look at Z first, and I'll show you the other alternative for X. So if we go to Y to Z, okay, the other route from Z to get to V is YZV. Now, obviously, you don't want to go YZ, Y in this case, because you're going to be traveling more than once. So there we go. The answer is at least 2 in this case. What we're going to do now is going to have a look at what happens if we go through this way. What if we go to Y X? Okay, and if we go through YX, we have to end up in W. So YXW is that pathway. Now, when we end up in W, we can go to V. Okay, so the one solution to this is to go straight to V from this one. Another solution to this one could be going to, we can't go to X, because if we go to X, we'll end back in W again. So if we go to W to Y, that won't work out, because we're revisiting Y. And if we go to W to Z, okay, what happens if we go to Z? We can go to V from that point, or in this case, that's really it. So you got 4 potential paths to go from Y to V without revisiting. Alright, next one, question 6. It said matrix P, Q, and R are square matrices. Inverse of matrix of Q. So inverse of Q is equal to P. Matrix R is the transpose of matrix P. And you can see in this case, we can also make the assumption that the inverse of P is also Q, because there's that reversibility that exists there. So it says all 3 matrices are defined if. Now let's look at the fact that all these 3 matrices, so we've got R, P, and Q, they're all related to each other. So if one is not defined, the other one will also not be defined. Let's have a look at the determinants, because the determinant, remember, if the determinant of a matrix is 0, it doesn't have an inverse, and it's not defined in this case. So its inverse is not defined. So you can see with Q, you've got 2 times 4 minus 8 times 1. That's not defined. Determinant for this one is 0. And determinant for this one is also 0. So we've got to be very careful now with this one, with A and B. Now with A and B, we're not talking, we don't, if you just look at the first instance of this question, you would say B is the correct answer, because obviously this one here has an inverse, a determinant of 0. But we just need to make sure we check this, because R is the transpose of P. So, so we should have checked that for this one. So the R is a transpose of P. In this case, sorry, just a bit of a mess up there. So I think you need to find the transpose of that. In this case, we just need to make sure the determinant of this is not 0. So in this case, B is in fact the correct answer, this one, because the determinant for that one is 0. Alright, so this particular question wants to have a matrix that ends up with 2 conditions. The total number of cakes sold in the week and the total number of sales from selling all the cakes. So, when we have this particular matrix, we've got sale prices and number of cakes sold, and it seems like we want to be able to add up all the matrices, A plus B plus C plus D. And then, sorry, we don't want to add those up. We want to add E plus F plus H. Okay. And then from this point, the sale price, you want to go the number of cakes that you sold times the sale price. So AE plus BF plus CG plus DH. Okay, now from this point, if you look at each of these responses, A won't get you that. A will only get you that total number of sales. If we look at this matrix here, okay, again, this really will solve nothing. It's just A times E, B times F. It really doesn't get you anywhere with this one. We want this condition here, the total number of cakes sold each week, to be the summing. So it's got to be either between B and D in this case. Now, if we look at A, B, C, D, we'll go A times 1, B times 1, C times 1, D times 1. That just adds up the sale prices. That doesn't actually add up the total number of cakes sold. So if we look at this, E, F, G, H, okay, D will get you that final matrix that you require. Okay, next one. Alright, now it says how many of these statements are true, and when we're talking about this particular transition, we've got a transition matrix here, and we've got S1 over here. Now, you'll have to use your CAS with this one. I've gone through the working of this, but we'll look at how many of these statements are true. So it says the first one, the highest number will always be K. So if we go through one transition of S1, we actually find that the highest value in this case, for J, K, L, and M, this is not the highest value. So in fact, that statement there is false. Now it says here all 4 numbers in the matrix S0 are equal. Now we're given S1. So in order to get S0, we can find the t to the power of minus 1 of S1. And that'll give us S0. And when we actually do this, we find that all the numbers are equal. Yes. Now, the next one says 30% of workers at L one week will remain at L the following week. So the loop, in this case, that is true. Next statement says of the workers who started at J, 20 will still be at J 2 weeks later. Now, we don't really know that at this point. We could go through a couple of transitions. So I'm guessing for this one we could go through to S2. In this case, this one's actually not true. And the last one is, in the long term, the number of k is going to be to the power of, equal to 152. When we go through transition to the power of, say, 50 times S1, we do get 152 there. So in this case, that's correct. So C is the most correct answer for this one. So when you use m times n, it's the summing matrix. So you can see that 47 plus 96 plus 52 plus 75, that'll be multiplied by all the ones, and you'll end up getting the sums of the rows in matrix M. For the second question, you've got H and G. You've got the resulting matrix, but you don't have the original matrix. So for this one here, G times H will give us a 3 by 5 matrix. So if we look at the 3 by 5 matrix, okay, there would have had to been two other matrices here. Okay, and H is a 4 by 5 matrix. Okay, and in order for this to result in a 3 by 5 matrix, this number here has to be a 3. And in order for it to be defined, this has to be a 4. So in this case, our answer is 3 by 4, which is B. Now, if you look at question 3 talks about a transition matrix, and it's asking you to relate the transition matrix to the actual diagram. Now, if we look at these elements, I'm really going to focus on what is not correct in this place. So I can see, and I'm going to focus on these particular elements here and here. So you can see with this one, D to D doesn't equal that. In this case, we've got 73. That doesn't equal that as well. So, that means D to D, which is this part here, which is 80%, which means that A, B, and C are only the possible options with that one. Now, the next one here is D to A. So D to A focuses on D to A. Okay, is that element there? So in this case, this is 9, this is 9. We want 11%. In this case, B is the correct answer for this question. Alright, so for question 4, it's talking about how there's an interview process going on. It's almost like a chain reaction that's going on. So it's asking us the order of the interviews. So, for example, if today you're going to be interviewing N, tomorrow you'll be interviewing J. So N, J. And if today you're interviewing J, tomorrow you're going to be interviewing P. And if tomorrow you're interviewing P, you're going to be interviewing R the following day. And if you're interviewing R, you're going to be interviewing, so where's R? Sorry, R is L. And then after that, after you interview L, you're going to be interviewing N again. So in this case, if we follow the list of which one's correct, we have got C as the correct answer because we've got L, N, J, P. Now, next one, it says, the set of linear equations does not have any unique solution if the value of Q has what? So it does not have a unique solution, means that the determinant's equal to 0. So if we solve 2.25 is equal to 0, and if we solve for Q, we get 1.8. Okay, so for this next one, question 6, it talks about 1 and 2 step dominances. In this case, the answer is E. The way we can do that is by looking at the sums. So this is 2, 1, 3, 1, 3. And if you square this matrix, so if we call that t, t squared will equal a particular set. If we add them up, we get that the answer is in this case. Now, question 7. Now, with question 7, it's asking us about how there is a particular movement of people around each particular path. Now, it says if we've got A, B, C, and D, first day, 40% of rodents. So, in this case, we've got 40, and then 20% were in each of the other locations. So, 40, 20, 20, 20. Okay. Now, it says on here on the second day, 1,000 rodents were observed in sheltering location A. Now, 1,000 rodents. If we set up this equation, we end up with 50%, 34%, 24%, and 12%. And that's after we find T2. So T2 will result in this. Now 50% of this means that if you saw 1,000 rats on the first location A, and you've got 50% of them appearing there, it means you had a total of 2,000. Now this last question here, I have had to look at this quite repetitively. However, there is a statement from VCAR saying that the way to do this question would be to look at the transpose of this equation, because really the only way you can see these results is that if you've got DEF and TUV here, there's no way that the columns multiplied with columns will give you that particular answer. So you'll actually need to find the transpose of this particular equation. So you've got A, B, C, and T, U, V. Okay. And then from this point, we can call this NT. Now, to find the answer for this one, we find the N transpose, and we multiply that with M. Then you'll end up getting D as the correct answer. And unfortunately, this is the only way that you can really do this. And VCAR have also said that, unfortunately, this is one of the methods.